This video is going to cover question 6, part A from the 2022 AP Calculus AB free response section, calculator not allowed. I will cover parts A, B, C, and D in their own individual videos, so if you're looking for one of the other parts of this question, go ahead and find that video on my channel. So this question is kind of interesting because usually we see just a single particle moving along an axis. This problem had two particles. So part P here, particle P is moving along the x-axis, and particle Q is moving along the y-axis. Both of these were just good for times t greater than 0, and then they gave us for particle P, that's always fun to say, particle P, they're giving us a position function to work from, and particle Q, they're giving us the velocity function to work from. And then from there, they give us a little bit more information on particle Q. So at time t equals 1, they tell us the position of that particle right there. So at t equals 1, the position of particle Q is 2. So let's see what's going on with part A. Part A wants us to now find the velocity for particle P, right? So all this little subscript stuff is great fun, right? When we're doing this type of work, this is where they want us to understand the physics relationship that they like to work with all the time. So if I have an original function that is my position function, the derivative of position is equal to velocity. And then the second derivative of position, the first derivative of velocity is equal to acceleration. So on this problem, we're starting with a particle P's position function. So we're starting here at the very top, and what they want from us is they want out of us the velocity function. So what that means is we just need to take the derivative of our position function to get that velocity equation. So we start off with x sub p of t, all the notation, great fun, right? So 6 minus 4e to the negative t. I like to put these things in parentheses when they've got like e to the negative t, just to remind myself that there's something inside that e function. It's true of a lot of these log equations and cosine equations, trig equations. They like to drop that. I like to keep adding those parentheses in. So as we move through here to find our derivative, to find our x prime sub p of t, our velocity equation, we just work our way through it. Remember that the problem's broken up into smaller bite-sized chunks by the pluses and the minuses. So the derivative of 6, that's a constant. The derivative of a constant is always 0. Then as we come through here, what we're looking at is the derivative of e, which I call these types of derivatives special case derivatives. And what I mean by that is these are derivatives that you just have to have memorized. If you have it memorized, great. If you don't, you're never probably going to guess it. So on e to the x, the derivative of e to the x is e to the x. The key on any of these special cases is as soon as that is anything more than just an x inside there, now we're looking at a chain rule problem. So it doesn't matter if it's a negative x, as soon as it is anything more than just your basic x, you are looking at a chain rule. And so here we definitely have something more than just our basic x, so that means we're going to have to apply the chain rule. So chain rule, product rule, quotient rule, you better have some saying, some recipe memorized for those or when you go into this test. My chain rule recipe that I use goes d in times d out. The derivative of what got plugged into that original special case times the derivative of the outside piece, which is just the special case. So in this problem, my inside piece is negative t. So the derivative of the in there, that would be a power rule. Bring that unwritten one down, you get negative 1. Subtract 1 from the power, and you end up with t to the 0. Then we go through and do the derivative of the outside. Well, the derivative of the outside, that is just our special case. That is our e function. So the negative 4 comes along for the ride, and then we get e to the negative t. And then from there, I would go ahead and probably -1 times -4 is going to get us +4 e to the -t. And so that's going to be our answer for our velocity equation on this one. So finding that velocity equation, not too rough as long as you remember your physics relationship. And then, they don't actually reward you too much on this because that's just going to be 1 point out of the 9 points we have available. So we'll follow up with B, C, and D in the next videos. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.